Assalamu alaikum dear students. How are you all? I hope you all are fine by the grace of Almighty Allah. Welcome back to Higher Mathematics 2 class. In this class, I'm going to start a new chapter, chapter 3, complex number. First of all, we have to know what is complex number. A complex number is a number that can be expressed in the form a plus ib, where a and b are real number and I represent the imaginary unit, satisfying the equation I square is equal to minus 1. That means I is equal to square root of minus 1. Because no real number satisfy this equation, therefore I is called an imaginary number. Okay. For the complex number a plus bi, a is called real part and b is called imaginary part. Okay. And the set of complex number is denoted by using the symbol C. Complex number allow the solution to certain equation that have no solution in real numbers. For example, look at this equation. Here x plus 1 whole square is equal to minus 9. We know that the square of any number is always positive, but here you can see that x plus 1 whole square is equal to minus 9. Therefore, this equation has no real solution, since the square of real number cannot be negative. But complex number provide a solution to this problem. The idea is to extend the real number with an indeterminate. I is known as indeterminate, and sometimes it's called imaginary unit. And I satisfying that this equation, and the solution of this equation are minus 1 plus thrice I and minus 1 minus thrice I. If we put here minus 1 plus thrice I in place of x, then we get minus 1 and plus 1 vanish, and 3i square, that means 3 square equal to 9 and I square is equal to minus 1. Therefore, we get minus 9. Again, if we put minus 1 minus thrice I in place of x, then we get minus 9. Okay. So, complex number allows solution to certain equation that have no solution in real number. Okay. Complex number. If z is a complex number, then z equal to a plus bi, where a be a real number and I is the imaginary unit here, or indeterminate. Okay. And I is equal to square root of minus 1. This a and b are real number, and we know a real number can be positive, negative, 0, etc. Okay. If b is equal to 0, then z equal to a, that means z equal to real number. So it is observed that real number is subset to the complex number. Okay. And if a is equal to 0, then z equal to bi. This bi is called purely imaginary number. So complex number can be a purely imaginary number. Okay. Number line or real line. If you take a point 4 on this number line, then you get this. And if you multiply 4 by minus 1, then you get minus 4. And position of on minus 4 in number line is this. Therefore, you can see that if we multiply a number by minus 1, then the number is rotate 180 degree. This number rotate 180 degree. Previous position this, and if you multiply minus 1 by this number, then you get minus 4, and this minus 4 is rotate 180 degree. Okay. And minus 1 can be separated into square root of minus 1 into minus 1. So আমরা এখানে দেখলাম minus 1 কোন একটা নাম্বারকে 180 ডিগ্রি রোটেট করছে। minus 1 এর পাওয়ার হলো কোন একটা নাম্বারকে সে 180 ডিগ্রি রোটেট করতে পারে। ওকে। তাহলে স্কয়ার রুট অফ minus 1 এর পাওয়ার হবে কত? 90 ডিগ্রি। কোন একটা নাম্বারকে যদি আমরা স্কয়ার রুট অফ minus 1 দিয়ে মাল্টিপ্লাই করি, তাহলে সেই নাম্বারটা কত ডিগ্রি রোটেট করবে? 90 ডিগ্রি। আমরা ধরলাম I equal to square root of minus 1, 4 into I is equal to 4i. And position of 4 is here, and multiplying by I get position of 4i is here. This I rotate the number 90 degree. Okay, that means this I moves along y-axis. Okay, now graphical representation of a complex number. X-axis, y-axis, and a complex number 3 plus 4i. Then graphical representation of this complex number. This moves real part. Here real part is 3 and imaginary part is 4. Then real part moves along x-axis and imaginary part moves along y-axis because I rotate the number 90 degree. Therefore, we get 3, 4. Therefore, graphical representation of the number 3 plus 4i is equal to this. Okay, এখানে x অ্যাক্সিসটা রিয়েল নাম্বার সেট ডিনোট করছে এবং কমপ্লেক্স নাম্বার সেট ডিনোট করছে পুরো এই প্লেনটা। তাহলে আমরা দেখতে পাচ্ছি যে রিয়েল নাম্বার সেটটা কমপ্লেক্স নাম্বারের তুলনায় কত নগণ্য, তাই না? রিয়েল নাম্বারটা শুধুমাত্র একটা লাইন রিপ্রেজেন্ট করছে আর কমপ্লেক্স নাম্বারটা পুরো প্লেন। ওকে, Argon diagram. With considering x-axis as the real axis and y-axis as the imaginary axis, the diagram on which complex numbers are plotted is called the Argon's diagram. So, if we take x-axis as a real axis and y-axis as a imaginary axis and plot the complex number, then the diagram is called Argon diagram. Okay, here this length is 3 and this length is 4. Now further from modulus and argument of a complex number. Argon diagram. We take any point P of xy on the plane, then this length is equal to x and this length ON is equal to x and this length PN is equal to y. And polar coordinates of PB are theta. Then this length OP is equal to R and this angle is equal to theta. So sin theta equal to, sin theta is equal to perpendicular by hypotenuse. Here perpendicular is PN and hypotenuse is OP, and here PN is equal to Y and OP is equal to R. Therefore we get Y is equal to R sin theta, and mark this equation as 1. And we know cos theta is equal to base by hypotenuse. Here base is ON and hypotenuse is OP, so ON by OP and ON equal to x and OP is equal to R here. Therefore x is equal to R cos theta, and mark this equation as 2. If we divide 1 by 2, then we get sin theta by cos theta is equal to tan theta, R vanish, and y by x. Therefore theta equal to tan inverse y by x. Is called argument or amplitude of the complex number z. Okay, and if we applying 1 square plus 2 square, then we get x square plus y square is equal to R square into sin square theta plus cos square theta, and we know sin square theta plus cos square theta is equal to 1. Therefore x square plus y square is equal to R square. Therefore R is equal to square root of x square plus y square. It's called the modulus or absolute value of the complex number z. Okay, nota bene, a complex number may have infinite numbers of arguments, but the value which satisfies the open interval minus pi to pi is called the principal value of the argument. The argument of the complex number z equal to x plus iy, x এবং y both পজিটিভ। তাহলে কোন কোয়াড্রেন্ট আছে এটা? ফার্স্ট কোয়াড্রেন্ট। ফার্স্ট কোয়াড্রেন্ট অবশ্যই ভ্যালুটা কি কার মধ্যে থাকবে বলো তো? 0 থেকে 90 ডিগ্রির মাঝে থাকবে। তাহলে আমাদের এই ইন্টারভালের মধ্যে থাকবে। এর জন্য আমরা tan inverse y by x টা লিখব। The argument of the complex number z equal to minus x plus iy, x নেগেটিভ y পজিটিভ। কোন কোয়াড্রেন্ট এটা? সেকেন্ড কোয়াড্রেন্ট। সেকেন্ড কোয়াড্রেন্ট ভ্যালুটা কেমন হবে বলো তো? 90 ডিগ্রির চেয়ে বড় এবং 180 চেয়ে ছোট। এবং এই ভ্যালুটা পাওয়ার সহজ উপায় হলো পাই মাইনাস tan inverse y by x. Okay. The argument of the complex number z equal to minus x minus y, both negative. That means this complex number lies in third quadrant, and if we take the positive angles of third quadrant, then it will be greater than 180 degree. That's why we have to take negative direction angle. That's why we write here tan inverse y by x minus 5. Okay. The argument of the complex number z equal to x minus iy, এখানে x পজিটিভ এবং y হলো নেগেটিভ। তাহলে কোন কোয়াড্রেন্ট এটা? এটা ফোর্থ কোয়াড্রেন্ট। এবং ফোর্থ কোয়াড্রেন্টে যদি পজিটিভ অ্যাঙ্গেল নেই তাহলে সেটা অবশ্যই 180 চেয়ে বড় হবে, 270 চেয়ে বড় হবে। এর জন্য আমরা নেগেটিভ ডিরেকশনের অ্যাঙ্গেল নিব এবং নেগেটিভ ডিরেকশনের অ্যাঙ্গেলটা পাওয়ার জন্য সহজ উপায় হলো মাইনাস tan inverse y by x. Now problem 1 of exercise 3, find the modulus and argument of the following complex number and express in polar form. Given problem A, 1 plus root 3i. Here x is 1 and y is root 3. So modulus are equal to square root of x square plus y square. So here 1 square plus root 3 square, and you get here 3 and 1. Adding 3 and 1 you get 4, and the square root of 4 is equal to 2. So modulus of the complex number is 2. And argument theta equal to tan inverse y by x and tan inverse y root 3 by 1, that means root 3, tan inverse root 3 is 60 degree. Therefore we get modulus is 2 and argument is here 60 degree, that means pi by 3 in radian form. Now polar form of the complex number 1 plus root 3i is equal to x plus iy, and x is equal to r cos theta. Here r is 2 and theta is pi by 3. So 2 cos pi by 3 plus I y, here I and y is equal to r sin theta. R is 2 and theta is pi by 3 here. And taking 2 as common, we can write cos pi by 3 plus I sin pi by 3. Okay, this is the polar form of the complex number. Okay, this is all for today. Thank you.